So hello everyone. My name is Mohamed Assaf. I'm from the University of Alberta, Canada. I'm going to present a topic titled Virtual Reality-Based Blockchain Application for Optimized Collaborative Decision of Model Construction. So we have 6 main sections in this presentation, starting from the introduction to the conclusion. So supply chain management and planning in offsite construction is a topic that is repeatedly studied by researchers. Researchers mainly look for the near optimum decision. They look for secure the information sharing to integrate different participants, to visualize the activities, to enhance the coordination and collaboration, and also to account for the physical attributes. In order to do so, researchers they always use different techniques. These include the operation management methods, such as the simulation and optimization. And using this method, we can find the near optimum decisions, but this method lacks the other features. And we can also use the blockchain and BIM technologies. And using these methods, we can secure the information sharing in the supply chain. We can integrate different participants. We can enhance the connectivity and the collaboration. But again, we lack the rest of the features. And more recently, the virtual environments and the game engines have entered this game. And using these methods, we can visualize the activities, we can account for the physical attributes, but again, we lack the rest of the features. And that was the motivation behind this research. We searched for an integrated approach that combines these technologies together. So we're looking for collaborative decision, near optimum decision. We're looking to visualize the activities, to secure the information sharing, and to enhance the connectivity and the coordination using the multiplayer functions. The specific objectives of this research, first, to provide the offsite construction participant with near optimum decisions to improve the performance of this supply chain. Second, to develop virtual environments to test these decisions, and also to enhance the coordination and collaboration among the offsite construction teams. And lastly, to promote the use of these virtual environments using the web function and the multiplayer functions. In the methodology, we have 3 main modules. They are connected with one another. So the first module is the simulation module. Here we use the hybrid simulation of discrete event and agent-based simulation. And here we try to optimize a number of KPIs or key performance indicators, including the cost, time, and emission KPIs. And we use the analogic tool as the main tool for the simulation. And then we try to test the feasibility of this decision in the virtual reality module. So we used BIM and game engines, which was the Unity editor and the Revit tool. And we developed virtual environments for each of the supply chain stage. And finally, we tried to promote the use of these virtual environments by developing the multiplayer and web-based model. So we used the near blockchain to enforce access control in these web-based virtual environments. And also we used the WebGL along with the Unity editor to develop the web-based models. Supply chain can take various forms, and here we are focusing on a very generic one that includes road and sea transportation. We have 3 main factories that we're sending precast and prefabricated elements to the site. So the first factory was sending precast elements or prefabricated steel girders to be manufactured in the factory number 2. And once this steel module shown here is manufactured, then it will be shipped to the site using sea transportation. And then also the factory number 3 was sending precast slabs to be installed on top of the steel modules. For the first module, which is the simulation module, you can track which module we are talking about by the legend on the top right. So we did develop discrete event simulation for each of the supply chain processes. This include the manufacturing on-site or logistics. And these processes were connected to one another using the agent-based simulation. So once we reach an end of the discrete event process, then it will inject a certain resource. For example, this is the truck, and the truck will behave in a certain way, and then it can invoke the second process and so on. Through the simulation, we evaluated different KPIs, including time, cost, and emission. Then we developed a GUI to ease the use of the simulation model, so the user can input their decision in this panel, and then they can explore the statistics of the supply chain using the rest of the panels. And then moving on to the virtual reality module. So we develop different scenes to test the feasibility of the selected decisions, and also to enhance the coordination and the connectivity between the offsite construction teams. So for example, we have the explore scene, and we have the logistics scene. As you can see, for example, in the logistics scene, we can have real-time update of various KPIs. So for example, this is the clearance, which is continuously updated through the simulation. We also develop a lot of on-site scene. Through the virtual environment, the user can see continuously updated variables, including time, emission, and the clearance of the precast element. And then we develop GUI to use to ease the access to these virtual scenes, so the user can choose whatever scene they wanted from the GUI. They can also configure the option or review the instruction for the virtual environment. And then we try to have multiplayer function in the virtual scene. So in Unity Editor, we converted all of the mono behavior to the network behavior. And the way this works, the server will be first initiated on the Unity Editor, and then clients can request to join the server or to join the same virtual environment at the same time. And then we test the problem that now the participant need to be in a VR facility to access this model. So we develop web-based models. So no matter where the participant is, they can just put a URL in any web browser, and then they can access the model. And for that, we use the WebGL and the Fishnet multiplayer library. We then try to have access control in the virtual environment. So we use the near blockchain, and the near blockchain would have or would enforce access control, and will have a near wallet for each participant or for each organization. And we use the same network to share real-time data about the supply chain. These are some of the results for the cloud simulation model. So once the user input their decision and hit run, they can explore the statistics for each stage. So for example, this is the manufacturing stage, and the other picture is the overall statistics. So in the manufacturing statistics, they can see the cost, the inventory through the simulation time. They can see the emission of the manufacturing, and in the overall statistics, they can see the components or the cost components for each supply chain stage. They can see the emissions for each stage, the time for each stage, and so on. We then tested the multiplayer function. So these are two different PCs, and once a virtual object is controlled by one team in one PC, it will be automatically synchronized in the other scene. We then try to test the blockchain network, and once one user establish the server, then the other user first need to sign in to the blockchain network. Once they are signed in, they have access to the virtual environment. And then if they click on this button here, on the button in the blue color, they can access the simulation or the analogic model. And we tested this multiplayer function using chat function. And as you can see, the chat function or the chat is synchronized between both screens. To conclude, the paper presented an integrated approach that combines operation management, virtual reality, and the blockchain methods to overcome the limitation of the offsite construction supply chain. The proposed model provides multiplayer functions that allow more than one user to access the virtual scene simultaneously to provide better coordination and better informed decisions. In the future, we will focus on how to integrate or to completely integrate the logic model or the simulation model with the virtual objects in the Unity editor. And also we will look into how to integrate the IoT sensor to facilitate near-time data for better data traceability and visualization. You can access the cloud simulation model if you scan this code. It can work on your phone, and you can access a sample scene of the virtual environment if you scan the other code, and this only works on the laptop. Thank you.